Hey, what's up, guys? Welcome to Unit 2, which is equivalent expressions. And I'm super excited to dive into today's lesson because today what we will see is really, this kind of is the foundation of what makes pre-algebra, which is the beginning of algebra, unique, right? And so in algebra is where you have these unknown values, and we refer to these unknown values as variables, often shown as the letter X, but also can be any other letter. Okay, and so today we're going to be talking about algebraic expressions. In previous grades, you've done some work with this, and so but there are going to be a lot of terms that maybe I'm using that maybe you don't know, and we'll be making sure we understand the vocabulary all throughout this unit. But in today's lesson, we just want to be able to model algebraic expressions using algebra tiles, which is what I have here, and just, being able to see sort of this representation, all right? And so being able to use manipulatives or to draw pictures that will represent the expression, all right? So let's go ahead and dive in. And so again, I have these tiles, and in class, I may provide these for you so that you can use them to construct some of the figures just so that you can see them. But when you don't have them, you can just draw pictures to represent them, all right? And so we have this white bar, which is usually referring to the yellow bar. So if you want to color this yellow, you can feel free to do that. And then we have a yellow or a white square, which represents 1. And so the yellow it always represents, matter of fact, let's change that to yellow. Well, I'm not going to change it to yellow because then you wouldn't be able to see it very well. But if you want to write this in yellow, yellow equals positive, right? And then this darker color, this is really red, and we'll just say the dark is negative. You know what? Let's not say yellow. Let's just say the light, or the white one is positive. The darker is yellow, is negative. And this one should have a negative sign with it. It should be a -1. Okay, that was left off there. All right, so the light is positive. This represents a positive X. This represents a positive 1. The darker, longer rectangle is a -X, while the shaded square is a -1. All right, so this first part should be easy peasy, right? All I'm doing is I am, writing the algebraic expression that represents the model. Okay, so here I have 1, 2, 3, 4, 5, 6. I have 6 X's, right? So each of these is an X. Okay, and I have 6 of them. So the algebraic expression would be 6x. Okay, I'm gonna just say this word now. The 6 is what is called the coefficient. It is the number in front of the letter. That is the number that's being multiplied with the variable. And then the X is the variable. Okay, so coefficient, variable, you're gonna hear me say those terms a lot. So I just wanted to introduce them here. All right, then next, let's move over. Here we got, these are -1. So we got -1, -1, -1, -1, -1, -1, -1. All right, and so when we add those up, the expression would be just -11. All right, so those are pretty straightforward, right? We're counting and we're writing the expression, right? We're going from the models to the actual numbers and letters, right? So here we got, these represent -X. So we got -X, 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 and then we have 4 of these, okay? And so to write the algebraic expression, it would be -4x, okay? I want to go ahead and mention something right now that's important to understand. When you are dealing with variables and say it doesn't have a number in front of it, right? In this case, it's just -x. I want you to know there is always this sort of invisible 1 in front of it. In other words, it is really -1x, 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 -1x. And then, in seeing that 1, 1, 1, 1, add up all of that, that's how I get the negative 4, okay? And so it is going to be important that you understand that, an x with no number in front of it is the same thing as negative 1x, right? It's just one, I just have 1x, okay? But that is important. It's going to be really important in future lessons, so I wanted to go ahead and mention that now, all right? Next, we just have, these are all ones, and the lighter ones are positive, so we have 9. And I want us to put plus 9, okay? You don't have to put plus 9. It is just a positive 9, but I want us to understand a lot of times when we're writing these expressions and we have the positive, the plus sign is going to come behind it or be with it, all right? So, guys, pretty simple. I want you to go ahead and pause it, and I want you to do the next 4 on your own. This time you're going to be combining some x's and the numbers. You're going to be combining them together. But I want to see, again, I think this is easy. I want to see if you can do them on your own. So go ahead and pause this video and complete the next 4 examples. One, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. 7, 8. Oh, all right. Let's get to it. Just a little break. Okay, so let's do it. So first algebraic expression for this one. This is a positive x. These are negative 1s. So we should have got x and minus 3, okay? Again, you could have put 1x, all right? If you don't have to write the 1, oftentimes, you're not going to see it, but again, we just need to understand there is a 1 there in front of it, but x minus 3, all right? Look at the next one. We got a negative x. We got a negative x here. Then these are all 1s, all positive 1s. So we got negative x and plus 7, okay? So we got negative x plus 7 there, okay? Moving on, we got, these are all positive x's. Again, we can think about it in terms of 1x if that helps, right? And then we got a negative 1. So 1, 2, 3, 4, 5, we got a positive 5x, and then we got minus 1, all right? Then we got, again, positive x's. We have 4 of them, so we have 4 x's. Then we have 5, so then it's plus 5, okay? All right, moving on. And then we got negative x. Then we got positive 1, positive 1, positive 1. So we got negative 2x plus 3, okay? And then lastly, we got negative x, negative x, negative x, negative x, negative x, negative x, negative x. So 1, 2, 3, 4, 5, 6, 7. So negative 7x, and then we got negative 1 and negative 1 for a grand total of negative 2. All right. So hopefully that was pretty straightforward. Let's continue. Oh, you know what? I do want to mention this too. We don't always have to put the x's first in the number or the constant after. It can be switched, okay? And so I want you to also know that. I think it would be helpful for you to at least go ahead and write that. You can also write this negative 3 and then plus x, all right? So that's also could be true, all right? Also, I don't have to, I could have wrote the positive 7 first and then wrote them negative x. Same thing here. I could put 5x minus 1, or I could put negative 1 plus 5x, okay? So we need to understand that both of those are true, okay? So in this unit, we're talking about equivalent expressions. So we're just showing different ways to essentially write the same thing, all right? And so when we get into the next couple lessons, we're going to be talking about simplifying these expressions, and that's all we're doing. We're taking this picture is the same thing as that, which is the same thing as that. It's equivalent expressions. It's just different ways to write the same thing, okay? So we have a couple more examples. So at this time, that's all for the instruction. I want you to pause it, and I want you to continue working. You have 6 more problems on the right side of your paper to complete yourself. And then once you get done, I want you to check them. Again, please do not continue to watch this video. It is super important that you pause it and then that you check your answers. Use the video simply to check your work, all right? So pause it and let's do the next 6 examples. Negative x plus 1, 2x. Oh, hey friends, I am sorry, that was my mistake. You should not have paused the video because I actually have to teach you a little bit here. Okay, so we now have models, but this time we have both positive and negatives of the same. Okay, and so we have to do something to simplify them. All right, and this is what's called zero pairs. I need you to say zero pairs. Okay, zero pairs. What that means is when you have a positive and a negative, those will cancel each other out, and so it makes a zero pair. Okay, and so what's going to happen is when I form a zero pair, okay, I could write negative x, a positive x, positive 1, negative 1, and then a positive 1. So what I could do is I could combine these two, negative 2x plus x plus 2 and then minus 1. Now I could do that, and that's going to give me sort of a much longer expression. Or what I could do is I could, because this is a positive, this is a positive and this is a negative, these two are going to cancel each other out. So that's a zero pair. And then because this is a positive 1 and then this is a negative 1, I can combine those two and they're going to cancel each other out and give me 0. So all I am left with, again, these two are out, they're out. These two are now out. So now I'm left with 1 negative, so negative x, and then positive 1, okay? And so really, again, this is technically right, but it's not simplified. In other words, this is the simplified expression for this model, okay? And so real quick, just to show you, if you did write this, what you would then need to do is you would then need to combine the like terms. And the like terms are when you have either the same letter or not, okay? So to be like terms, it has to have the same variable. And then these two both don't have a variable, so they are like, so I would combine these. So negative 2 plus 1 is going to give me negative x, and then a positive 2 minus 1 is going to give me a plus 1, okay? So that is how we got that. But again, this is a lot more work. I just need you to understand with the models, all you have to do is form zero pairs, all right? So let's look at the next one, all right? So again, we got a negative x, we have positive x, positive x, positive x, positive 1, and then a negative 1, negative 1, negative 1, okay? So to simplify this and write the expression, I want us to find zero pairs. I want you to put a star beside that, okay? Again, with zero pairs. Zero pairs is the key here, all right? So a zero pair is when you have a positive and a negative. When they come together, they're going to cancel each other out. So negative x and a positive x, that forms a zero pair, okay? So I don't need that. Then this positive 1 and this negative 1, that forms a zero pair. So I don't have to, again, they cancel each other out, all right? And so now what am I left with? I'm left with, well, 2 positives, so 2x, and then 2 negatives, minus 2, all right? So with that said, I'm going to do one more, and then I'm going to let you do the last 3 on your own, okay? So I'm looking for zero pairs. So I have 5 x's, positive x's, 3 positive 1s, okay? So I'm looking for zero pairs. Well, I don't have any x's that are positive and negative, but I do have 1s. So this right here is a zero pair. They cancel out. This is a zero pair. This cancels out. And so This is also a zero pair, and then so those cancel out. And so now I'm left with 1, 2, 3, 4, 5 positive x's, and then 1, 2, 3, 4 negative 1s. Okay? All right. So I just want to show you one more time using, actually no, I'm not. Zero pairs is kind of the way there. All right. So you have 3 examples here, and I want you to, here's where I want you to pause it for real, and to answer the next 3 questions, and then allow me to help you by checking it after you're done. So again, for the next 3, I want you to try to form 0 pairs to answer these, and then check your work with the rest of this video. All right. So the 0 pairs would be, again, it's kind of hard because they're not side by side, but these 2 with these 2 would form 0 pairs, because that one with that one, that one with that one, that forms a 0 pair, so they cancel out. So now I'm left with negative x, and then 1, 2, 5, 6, 7, 8. So that is negative 2x plus 8. All right. Next one. Again, these 2 would be my 0 pairs, right? This one with that one, this one with that one. That's the 0 pairs. And now I got negative x, 1, 1, 1, 1, negative 1, negative 1, negative 1, negative 1. Also, these are 0 pairs, right? Each of these have a 0 pair, so they cancel out, all right? And so therefore, I'm only left with the negative 3x, all right? And then lastly, okay, again, negative x, x, positive 1, 1, 1, 1, negative 1, negative 1, negative 1, negative 1, and then a positive 1, okay? And so these, again, these are my 0 pairs. This one with that one, this one with that one. This is also a 0 pair, this is a 0 pair, this is a 0 pair. So all of these 0 pairs cancel out, right? And then I'm just left with a positive 2, all right? And so again, I forgot to kind of mention this when I was going through this. I just need you to also understand that, again, I could have written this negative 4 plus 5x, all right? Or I could have written this 8 minus 2x, okay? Or I could have also written this negative 2 plus 2x. Or again, I'm just switching them, right? Or I could have put 1 minus x. So again, those expressions are all equivalent, right? You can switch them. That is called the commutative property, where you can move it, right? 5 plus 4 is the same as 4 plus 5, right? So that's no big deal, all right? So last thing, we're almost done. I know this video is getting long, but wanted to get everything in. The last thing we're gonna do is you're just drawing the model, okay? Hey, listen, there's many different ways you could draw it. I'm gonna ask you in this lesson to just draw it the simplest way, okay? So if I got negative 5x's, then I just need to draw 5 shaded rectangles, okay? That's all I need to do is draw 5 shaded rectangles, and that would give me negative x, right? And then if I want negative 2, I'm just drawing 2 shaded squares. Easy, all right? Same thing, if I'm drawing 4, I'm just drawing 4 white ones. Then a positive, I just want 1 long, all right? And then y'all got this. I'm positive 4, so I'm drawing 4 of those, and then a negative x, I'm drawing a long one that's shaded. Okay, just use your key to help you. Now, I did the easy ones. Now it's your time to do the hard ones. Hey, hope this lesson has helped you. In this lesson, we learned how to model and to represent equivalent expressions using algebra tiles and picture representations.